Hey guys, welcome to AlgoYogi, and the next problem we are going to solve is subtree of another tree. Let's go to the problem on LeetCode, and the description says, given the root of two binary tree, root and subroot, return true if there is a subtree of root with the same structure and node values of subroot, otherwise false. So basically, we're given subroot and root. Root is the bigger structure. It could be equal to subroot. However, we are just trying to find if subroot is present in our root. So now here it is, and by presenting, by subroot being present in root is the value of the root node of subtree, and the entire structure of subroot has to be equal to that particular subtree that we have found in our root. So if we are trying to understand how we are going to approach it, it would be basically we iterate over our root, and then whenever we are coming across the value that's equal to the root value of subroot, that point we will call the function that we have already implemented previously, is called isSameTree. Right? We are given P and Q to two trees, and then we are checking if they're both equal. And by equal, we mean the values have to be equal, left and right subtree, the entire structure of P and Q have to be equal. So we'll have to call the same function isSame on left of P and left of Q and right of P and right of Q. So the same thing we'll be doing here. We'll be making use of isSameTree algorithm here. So basically we'll have that as a function, but then we'll be calling that function once we find if there is a value. We only want to check if the values are equal, right? We found this for somewhere in here, like we have done here. In this case, it's basically returning true, but it might not always be true, right? So we're basically we're iterating root 3 is not equal to 4, then it's gonna check in the right and left, and then in right it is equal, so it's gonna call the isSameTree on this as Q and this as P, and because they are equal in this case, it will return true. Okay, so it's fairly simple problem. It's just we have to know that we have to make use of our isSameTree. Okay, so let's implement the solution, and for a change, let's do the iterative solution this time. We have been doing the recursive solution for a while, but once in a while we should know that all these problems can be solved using iterative approach as well. So we're going to have stack containing root, and while stack, I will take out the current node, pop it out of the stack, and if current node and current node dot value is equals to my sub root dot val, then what I want to do, I want to call isSameTree function, and that will take basically current node, and it will take subroot. Is basically we're gonna have a variable called we have found it, right? So in that case, we can assign that value to some variable, right? So let's call that variable. What do we call that variable? Because we just don't want to return that, we just want to return it on, we will be calling it on all the functions, and even if it is just once true, then we return true. So it's like subtree found. Okay, that will be false in the beginning. So, and here we can say, I mean, this is not the right way, but we can say SubTree 0 is equal to is same, but also this. What if we already found it, right? Or this value is true. And once it's done doing this, then what I want to do is I also want to call, you know what, let me have if current node as an outside condition and remove it from here, because we don't want to process the empty node after this. So, and in here I also want to append the current node dot left and current node dot right, so that we are processing left and right also, right? Okay, and finally we will return this. We haven't implemented yet, okay? So remember that SubTree found, okay, 0, like 0th index. The reason we're doing it is so we can access it inside the inner function also. Wait, there's no inner function right now. Yeah, I mean, no need. There is no need. Yeah, there is no need of this. There's no inner function, because I was thinking about the recursive solution where we create the inner function. However, it's not needed right now. But let's say now, how are we going to implement this is same tree function? How are we going to implement it? Let's just call it, make it as inner function. And this is how we do it. And let's just call these P and Q, because it will become easier for us because we have already solved it. If P is none and Q is none, then we return true. If one of them is not none, which can be checked like this, elif or, okay, and then it will return false. What next? But we want to check if their values are similar and their left of P and left of Q and right of P and right of Q, they're also similar. We have done it in our previous problem, right? So let's copy this and check their values. P dot val equals to Q dot val, and on left of Q and left of P, and the same has to be true for the right subtree. Okay, simple. I'm sure because you have already written this problem earlier, so it would be easy for you to write. So I'm just quickly writing it here, not just going in deep of this function. Now this function will be called over here, and then we can return whenever it becomes true. So this will make sure we're processing all the nodes of our root, the left and right, and whenever their values are equal, then we are basically checking if their values are equal. Then we check if current node and subroot, they are same tree. So okay, let's run it. And we forgot to add, so this can happen. Oh my god, what's happening? Oh yes, this is, we were supposed to remove it. Okay, this is running fine, and let's submit it. Yes, so I would say like just go there and solve it, mark it solved on AlgoYogi. A better way to track your problems. Okay, now the time complexity. The time complexity would be big of n, but honestly it's not going to be big of n. It could be worst case, it could be that at every point all the values are similar except the when we go to the last node, so in that case at every point we are calling p and q. So for every node in subroot in our main tree, so this is what I was saying, that for every node in root, let's say they were all 4 except there was one little subtree that was equal to subroot, very little subtree, let's just call it 4 or let's just call it 2, but then and all the values were 2 also, then it will only match with that 2. However, at every point it's calling is same tree, which also takes big of n time because it's visiting all the nodes of those subtree, right? Honestly, in that case as well, can it come down to just n worst case? Because at the end of the day, we are only calling. We could call it on all this. So for safe case, we can just say it big of n square, right? And then for space complexity, we are also, this will be big of h, which is the height of the main root. Okay, this is done. You can also write the recursive solution, which is like way easy to implement, and I'm sure you can do it. So see you in the next problem. Bye bye.